Okay, let us see how we handle my examples here. We have a displacement of a particle after t seconds is given by that. Find its speed. You know that speed is magnitude of velocity. So it means we need to classify the velocity here, then we get its magnitude. So from there, our solution, or is our speed, is equal to magnitude of velocity. So it means we need to get velocity first. Know that our velocity is equal to differentiation of displacement s. So from here we need to differentiate this, so which will be d dt of our, you can give it in a column form or you can write it the way it is. 2 root 3 sine t I plus 8 cos t j. We differentiate this and we differentiate this. So this will give us, so from here, our value will be, when I differentiate sine, I get cos, so 2 root 3. When I differentiate that, this is a coefficient, so it remains. So when I differentiate sine, I get cos t. Cos t, this will be our I component, then plus. When I differentiate cos, you get negative 8 sine t. This will be our j. So meaning, this is going to be our velocity. So after t equal to pi, so meaning that this velocity can be, I can give it as 2 root 3 cos t, the I component, then the j component, negative sine t. So when t is equal to pi over 6, my v will be into now 2 root 3 cos, sorry, this is cos. Now t, pi over 6, that is 30. Then this will be negative 8 sine pi over 6. Okay, which will be, this will be 2 root 3. Then cos of 30 is root 3 over 2, then minus 8. Sine of 30 is a half. So from there, what we have is this is going that way. So this time, root 3 times 3, we get 3. So this will give us 3. Then this will give us a negative 4. So that's our velocity. So meaning, if you want our speed, so our speed will be magnitude of v, which will be the square root of get 3 squared plus negative 4 squared, which would be 5 meters per second. As simple as that. Okay, when it comes to this, the position vector of a particle is given by this. Find after t equal to seconds its speed, then magnitude of the acceleration. So, you know that we said, as we say, still our speed is given by magnitude of velocity. So, you need to get velocity first. So, you can say our r is given, we give it in the column form, plus t minus 1. Here you can see this is the j component, this is the I component. As simple as that. So our v is equal to d dt of r, which will be, we are going to differentiate. Now our r, this is 3t, then 4t cubed plus t minus 1. So in differentiate, 3t squared, we get 16. 16. When you differentiate 1, when you differentiate this 1, we get 0. How do you differentiate? You get this times this, then reduce this by 1. They add in 1. When you differentiate a constant, you get 0. When you differentiate this lower this and multiply it with this, you shall get 12. Reduce the power by 1, you get 2. Differentiate this, we get 1. When you differentiate a constant, you get a 0. So our velocity now we get when t, okay, our v when t is equal to 2, it will be, now where is t, we 2. So it shall be having 6 into 2. Then here it shall be having 12 into 2 squared plus 1. So this will give us 12. This will give us 48 plus 1, which will be 49. So meaning our velocity after after 2 seconds, our velocity after 2 seconds is going to be 12:49. So meaning I can now get a speed. Remember our speed is magnitude of v, which will be the square root of 12 squared plus 49 squared. And from there, this will give me give me 15.448 meters per second. That's going to be our speed. As simple as that. Remember, they ask you speed, you just first get the velocity, then after get the magnitude of velocity. Then if you want acceleration, part B, remember our acceleration, first of all, we differentiate v. So but our v at time t was 60, then 12t squared plus 1. So this is our velocity at any time. So when you substitute there, dt of 60, then 12t squared plus 1. Okay, so when you differentiate that, so our acceleration is going to be now, when you differentiate 60, we get 6. When you differentiate this, we get 24. T, when you differentiate 1, we get a 0. So this is our acceleration at any time t. You can write it as our acceleration at any time t. So when they want after 2 seconds, so our acceleration after 2 seconds, this means that rather than 3, we are putting 2. It will be 6 into 24 into 2, which will give us 6, and this will give us 48. 48. So they want us to get the magnitude of the acceleration. So magnitude of this acceleration is going to be 6 squared plus 48 squared. And so this will give us 48.3735 meters per second squared. And that's what we have. This is also meters per second squared, and so this is meters per second. So that's how we handle that. Whenever they ask for speed, get velocity, and after get its modulus or magnitude. Whenever they ask for the magnitude of the acceleration, you do the same. Now, if they ask distance, get magnitude of displacement after that time. As simple as distance is a scalar. So the magnitude of displacement, as simple as that. See you in the next lesson.